Hello, I'm Brenna.
Hi, I'm Ben, and we are FTC Team 14175 RoboRavens.
This is a step-by-step Fusion 360 tutorial that will teach you how to make your first 3D model. This is not a tutorial for installing the software, so if you've not already done that, then you need to do that first.
Before we get into Fusion 360, let's talk about 3D printing.
To give you a super short, non-complicated definition, 3D printing is making a physical object from a digitally constructed 3D model.
We have used 3D printing for many things on our robot, such as grabbers, phone holders, wheel adapters, and more.
3D printing is great for beginning teams who do not have a lot of money to pour into expensive robot parts. It is also great for teams who want quick prototyping. However, if you want to start 3D printing, you will need a 3D printer, a modeling software like Fusion 360, and that big ball of jelly that you call a brain.
Now that you have an idea of what 3D printing is, let's talk about Fusion 360. This tutorial will cover on how to work within the Fusion 360 interface, and it will also show you how to create your very own Rev battery case to use on your robot. Now, let's jump into the software. Alright, now that we have Fusion 360 open, let's start talking about the user interface. The toolbar, which is at the top of your interface, shows all the main tools that you will need to create your model.
You'll notice that if you click on the drop-down arrows, you should see all of the available tools in each category, as you can see here in the Create tab. Another important feature is the Browser tool. It will show you all of your components, bodies, and sketches in a file structure. You can toggle which bodies are visible by clicking on the eyeball button. You can comment on your team's project by typing in the text box. This is a great way to collaborate with other members and send feedback, especially outside of regular team meetings. If you want to comment on a specific project, component, point, or image, use the different comment buttons below the text box. Next, we have the timeline. The timeline will show up at the bottom of your workspace and will keep a running list of commands that were used to create your model. As you can see here, when I created a sketch and then extruded the model, both actions were recorded by the timeline. If you need to go back and edit a specific part of the model, just select the action in the timeline that you want to change.
Next are the display tools. These can be accessed in the smaller toolbar at the bottom of your workspace. Some examples are the View Cube in the upper right-hand corner, the Orbit tool, and the Zoom tool, both of which can be accessed on the toolbar at the bottom of your screen. To use these, you can either click on the appropriate button on the display toolbar or use a specific hotkey. The Zoom hotkey is the scroll wheel on your mouse. The View Cube is in the upper right-hand corner, which you can use to navigate to different views of the workspace. Each side of the cube has different angles: left, right, top, and bottom. The Orbit tool allows you to drag the view around a model in an orbit. Now that you have a general understanding of the Fusion interface, we can create the battery cover.
The process of creating a model usually starts with a sketch, then to extruding, and lastly, modifying the object as needed.
To begin, we will need to sketch the base of the model. We can find the Sketch tool as a second option under the Create tab. Once you select the sketch, you should now be in the Sketch workspace. We need to select a plane to draw the sketch on. For simplicity's sake, we'll draw it on the bottom plane. Now we need to draw a rectangle for the base of the battery case. To draw a rectangle, we need to select the rectangle under the Create tab and then select Two-Point Rectangle. This will allow us to create a rectangle using 2 points for the diagonal corners. For now, I will just draw a random box and then we will dimension it later.
Now that you've made your shape, you're going to want to cancel out of the 2-point rectangle option. You can do this by right-clicking and clicking on the Cancel button. Now that you've done that, we'll want to dimension our sketch. This means we'll add our own values to the sketch to make it however big or small we want. To select the Dimension tool, you can either press D on your keyboard, or you can navigate to the Create tab and click on Sketch Dimension, all the way at the bottom. Now that you have that selected, let's dimension our sketch. You can do this by clicking on any of the sides and dragging out the drop-down menu. Once you have that, it'll give you the option to input some values. For this side, we want it to be 5 inches long. For the other side, you can do the same thing, and we want it to be 2 inches long. And there you have it.
Now that we have the correct rectangle size, we need to create the walls of the battery case. To do this, we can use the Offset tool, which you will find under the Modify tab, as you see here.
The Offset tool allows you to copy the original sketch and then scale it up or down a desired distance.
Now that we have the Offset tool selected, we must choose the line that we want to offset. I will first click anywhere on the rectangle line, and then we will input a value. We want the walls to be about 1/4 of an inch outside the original sketch, so I will input a value of -0.25. To complete the sketch phase, click the green checkmark button in the upper right-hand corner called Finish Sketch. This will take you out of the sketch workspace and back into the solid workspace for modeling a 3D object. To create a 3D object out of the sketch, we need to use the Extrude tool under the Create tab. This tool creates depth from a closed 2D profile. Once you have the Extrude tool selected, we need to select a profile. For the bottom of the battery case, we will extrude the center rectangle, as you see here, by 1/4 of an inch, or 0.25.
Now, here's where the timeline comes in handy. I will hover over the original sketch action, right-click, and select Edit Sketch. Now, we can go back and extrude the walls.
Because we are in the sketch workspace and it has different tools, we need to select the Extrude tool with the letter E on your keyboard. Then select the wall sketch profile. We want the walls to be 3 inches high, seeing as the Rev battery is 3.5 inches tall. This will give you 1/2 inch of room to access the battery. When you hit Enter to confirm the extrude amount, the timeline should reset to the last action recorded. If that doesn't happen, then just click and drag the slider bar to the last command.
Once the timeline is reset, the bottom of the battery case should now be visible, as shown here. However, we are not done yet. If I go to the browser folder and open up the bodies folder, there are 2 bodies shown. Interesting. The reason for this is that we extruded the walls and floor off of 2 separate sketch profiles.
You'll notice that when we hover over the different objects, they will be highlighted to inform you which one you are selecting. To fix the issue of having 2 separate objects, we need to use another tool under the Modify tab called Combine. Combine will perform a join operation on the selected bodies so they will print as one. After the Combine tool is selected, an info window will pop up showing the available operations that can be performed. First, let's select the target body, which will be on the floor. Then we will select the tool bodies, which are the walls. After you select OK, the objects will be combined together into one model.
Next, we need to create the cover. First off, I will click Create Sketch to get into the sketch workspace. We'll start with a random rectangle using the 2-point rectangle action. Now that we have the rectangle, we can modify the sketch with the Dimension tool. Then I can select the sketch profile that needs to be modified. You should notice that this is the same process that we used to modify the battery case earlier. We want the length to be 3 inches and the width to be 2.7 inches.
In this case, we could just go ahead and extrude the walls and the floor separately as we did with the battery case. However, I'm going to show you another tool to get the shape that we want. So for now, just extrude the rectangle to 1.3 inches. The tool that we want to use for this operation is the Shell tool, found under the Modify tab. This tool removes material up to a specified thickness. You can see that when I select the Shell tool, the options available are the faces to select and the direction that you want the material removed. We want the front face shelled to a thickness of 0.1. I'm going to use the view cube to move to the front face. and then select the face on the object as the side to be modified. The direction needs to be inside so that it removes the interior of the model. Once that is done, the model should look like this.
So now that we have the general shape of the lid made, there are a few more adjustments to make. Since this is going to fit over the battery cover, we want to make sure it can stay on somehow. We will do this by adding a sort of lock to the cover of the battery case. This lock system is going to be a channel built into the cover and case. I will go into detail about how exactly this will work later. So for now, let's start with the general shapes. All you should have right now is a rectangular cube with a pocket in it.
We want to start a sketch on the top of the model. One way to do this is by using the view cube and selecting the top view. Navigate to the Sketch tool under the Create tab and click on the 2-point rectangle tool. This time around, we are going to create an exact sketch instead of just placing a random rectangle. We can do this by clicking once on the model to place the sketch. At this point, I can only modify the length, but not the width. I'll deal with that in the next step. First, I will change the length to be 2.9.
Now that the value is in, I need to modify the second value. I can swap to the second value with the tab button. You'll notice that the first value is locked and can no longer be changed unless I swap back with the tab button again. Now that we have access to the second value, we can change it to be 2.3. Hit Enter to confirm both of the values. However, we are still left with a problem. The sketch is off-center of the model. We need to use a new tool from the Sketch workspace under the Constraint tab called Midpoint. This allows you to snap a line to a midpoint of another. First off, I will click Midpoint, then I will select the sketch. I will select the line that we want to snap to. As you can see here, the sketch is now centered, and we can go ahead with extruding the sketch.
So now, let's extrude the sketch. You need to select the Extrude tool and then select the top sketch profile of the object. The sketch will be extruded down to a value of -0.1. You'll notice that when the negative value was put into the extrusion action, it now takes away material or cuts into the object. Another thing to notice is that the operation was changed to a cut instead of a join. Since Fusion did it automatically, you might run into a problem where it will assume that you wanted one operation when you really needed another. Keep that in mind when you're modeling, as you might have to switch to another operation depending on your needs. Going back to the model, if you use the view cube and look at the front of your object, you should see that there are now 2 channels in the sides of your model.
Now that we have the battery case and cover, we need to make the final touches to the models. We want a way to keep the battery wires safe from being kinked or damaged. We will do this by making a hole in one side of the case model. I will begin by placing a 2-point rectangle sketch on one of the short sides of the case model, the short side being the one that is 2.5 inches long. We want to make this an exact sketch, so I will only click once to place the sketch, and then use the tab key to input 1.5 inches in both flyout boxes. Now that we have a 1.5 by 1.5 inch square sketch, we need to dimension it. Use D or look under the Sketch tab to find the tool. With the Dimension tool, click on the side of the sketch closest to the bottom of the model.
Now, usually we would just place the dimension line somewhere out of the way, but this time I'm going to click on the bottom line of the model. This means that both the bottom line of the sketch and now the bottom line of the model are selected. The new dimension line that we created will be for the distance between those 2 lines. Because we have a dimension line there, we are able to modify that distance to create sort of an offset from where the original sketch was. After I input a value to this new dimension line, the sketch placement should be that distance away from the model floor. The value that we want is 0.1. 25. Once I hit enter, you can see that the sketch snaps to that new offset location.
We will use the same dimensioning method to center the sketch on the model. Use the dimension tool to click on the right side of the sketch and select the rightmost side of the model, as you see here. Input a value of 0.5 and hit enter. Again, the sketch should snap to that location and should now be centered on the model. It should look like what I have here. Select Finish Sketch to exit the sketch workspace. Select the Extrude tool with E or by finding it under the Create tab. Extrude the sketch to a value of -0.25 so we cut away material. Now you have a place for the wires to sit.
Now we need the channels in the case so that the cover will fit. I will go ahead and create both sketches on the short side of the battery case, as you see here, that does not already have a hole in it. Now that I have both sketches, the two square sketches that you see are each 0.11 inches tall and 0.13 inches wide. You can place these anywhere near the top of the model, as we will dimension them next. Now I have the dimension tool, and we will need to select both the top of one of the squares and the top of the case model. The dimensioning value will be 0.15 inches. I will repeat this step for the other square.
The next step is to constrain the sketches to the sides of the model. I will do this by using a tool under the Constraints tab called Coincident. This tool constrains one or 2 points to a line or another point. I will click on the top corner of the sketch closest to the model edge first when I select the model outline. Once I hit OK, you'll see that the sketch snaps to the edge of the model. You can do this same step to the other square.
Now that both sketches have been constrained, we need to extrude them. I will select the Extrude tool from the Create tab and select both sketch profiles. If the sketches don't show up, you can just find them in the browser sketch folder and toggle visibility, as shown here. The distance to cut into the model is -2.9. This will automatically swap to a cut operation, so all we need to do is click OK. Next, we need to finalize the battery case by applying fillets to any or all of the edges to the battery case and cover. This will make your model look a bit nicer and remove any sharp edges. The fillet tool can be found under the Modify tab. The fillets are used to round edges of an object. After selecting the fillet tool, I will hold down the Shift button on the keyboard and select all of the edges to be modified. You can choose any of the edges that you want to round except the edges that are on the inside of the cover and case channels. You can also choose whatever size you want the fillets to be. Here's our final model with the fillets on all of the outer surface edges. At this point, the model is complete. However, feel free to use any of the other tools to modify the model as you like.
Before we end this video, we have a few things to add. We printed the model and noticed that there are some slight errors in how it's made. This is why 3D printing is such a great way to prototype. You can print your model, see that something needs to be changed, and immediately be able to make the changes and print it again.
This is the original model that we printed from the video. As you can see, the battery has way too much room. So to fix this, we will print this model at half the width. You can either change the setting in the 3D printing slicer or within Fusion 360 using the Scale tool. Here's the final scaled down model. As you can see, the battery almost perfectly fits in the new case.
Since both the cover and the battery case are now finished, this concludes our Fusion 360 tutorial. Thank you so much for watching. We hope you learned a lot from this video and we hope you enjoyed it.